So we hope to finish by half an hour's time. All right. First thing, don't copy. These are in the blackboard, and after this lesson, it will be made available. You can revise it as you come along, today or tomorrow. Yeah, it's all in the blackboard, so no need to copy. Don't waste time copy, just pay attention. So first thing, we had used this while loop quite a fair bit. Our state machine, one of the key components is the while loop. So the important thing about a while loop is that you need to understand two things. One is that this I, iteration count, and of course this particular symbol, the conditional terminal. Okay? So these two icons, you have to understand it. This I is a counter automatically updated as the loop executes. So when the loop executes one time, the first time, this I is equal to 0, not 1. That's why this word 0 index, starting from 0. So when you see I equals to 10, how many loops has it made? How many? 9 loops? Sure. If we make one loop, I equal to 0. So correct? So I equal to 10, how many loops? Huh? Don't get it. Don't get my question. Oh dear. I'm more straightforward. After one loop, what is I? 0 is a 0 index. It starts from 0. After first loop, I equal to 0. Got it? Second loop, I equal to what? 1. So you compare the number of loops and I. What is the relationship? I is always 1 less than number of loops it made. Got it? Give a few seconds to sink it into the deep memory. I is always 1 less than the number of loops it makes. If number of loops is 10, what is I? 9, very good. If I is 10, what is number of loops?
11.
Oh, 11. You get it. So the reverse question, you don't get it. So you better get the reverse question right. Okay, that is one. The second thing is this particular icon, which can change from this red dot to this continuous circular green arrow. These two icons means different things. So the 3 words you need to remember for one of them, you get it remembered carefully. These 3 words, stop if true for the red one. And then the other one is opposite, continue if true. This true refers to the boolean that you input into this icon. This icon has an input, it expects an input to be given to him. The input is either true or false, no numbers, it's a boolean. This green color box is a boolean. So you input a true to it, it will stop the while loop. For this one. But if you input a true to this continuous green arrow, it won't stop. Instead, it will continue forever. Okay? Alright. This loop here, example. How many times this loop will loop? How many times? 1, 10, 20, how many? Yeah, this question example here. I finished talking about the condition already. How many times you will loop? Don't get it. How many times?
99.
It's a trick question. You will loop it finitely. Stop if true. This fellow is false. Can it ever stop? It's a false constant. You put a false constant into this condition which says I only stop if it is true, and you permanently put a constant false to it. Can it stop? Cannot stop. So how many times you loop? Infinitely. Not 1, not 10, not 0, not 9, not 1 million. No, infinitely. You cannot stop. You gotta abort the program in order to get it out of the loop. Basically break the program. So get this part very clear. While loops. some question we tested on this while loop concept, which tests again the iteration count and your understanding of the conditional terminal. Case structure, another important part of a state machine, as you remember last week test. Okay, and case structure, obviously it has a case selector which you input a condition to it in order to turn to whatever case you want to turn to at that point in time. Of course, in our state machine, this particular object that is input to this case selector is the enum, which we put in a lot of items at different states. We put into this enum so that this case structure can change from state to state according to the state machine or the state program that you have programmed. Okay, so this state case selector, it can take in Boolean, true or false, only 2 cases. It can take in enum, many of them, up to you how many enums you want to key in items. You can take in numbers. However, numbers, there's a restriction, only whole numbers. In other words, integers, no floating point. Don't input a number 3.14. Oh dear, what case is 3.14? No such thing. 3 can, 4 can, 3.5 cannot. So no floating points, only integers. Strings can. Monday, Tuesday, Wednesday, Thursday, you run different cases to execute Monday, Tuesday events. Okay, so take note of that. Besides that, this is just part of the thing. So case structure, the case selector. This is to contrast for loops and while loops. Yes, for loops, we don't use it in our state machine. Why? Because a for loop has to execute a definite number of times, and state machine can execute forever. You know, if you don't put a stop case, it can execute forever. So for loops are not used in state machines. That's why you don't use for loops so often. But some other cases we need for loops because we know we want to execute a fixed number of times. And how do we do that? We assign a constant or a numeric or a variable that goes into this N, capital N input. This capital N input determines the number of times the for loop can loops. Okay? So the other contrast difference between the while and the for loop is that the for loop can execute 0 number of times. That means I input a 0 to this N, then it will execute 0 times. That means don't execute at all. But a while loop must execute at least 1 time. Because once the while loop is encountered in your program, it will definitely go into the code inside the while loop, execute once, then check the condition to decide whether to execute another time or not. If it is true, straight away you will exit the while loop and you only execute once. Okay? So if you want the while loop to execute once, you put a fixed constant to this stop if true condition. You put a true constant to this stop if true condition. Then this while loop will execute once. That's all. Then it comes out. Okay, the next time it comes in, execute once the code inside there, it comes out. Alright? But a while loop cannot execute 0 number of times. Cannot. Once it goes into the while loop, it must execute 1 time, minimum. Whereas for loop can. You put n equal to 0, the code inside will never be executed. Never. Okay, so this is the other main difference. And of course, as the loop loops, the data are being computed, whatever you want to compute inside this code can be output into an array at the output tunnel, and likewise, a while loop also can be output into an array, but you want to select the last value also can. This is not a key thing. How many times will this loop iterates? 50? These are the things that you need to understand. It's a for loop. The for loop says the n is 50. So straight away you think it's 50. You have to look a bit further. You look at the code itself. And the code, there is this particular very unusual condition to stop the loop. Most, if not for loops, don't use a stop condition. But some crazy programmers who likes to use a for loop, and before the for loop can complete the determined number of loops predefined for him to complete, the programmer chooses to break that for loop. So that breaking is not advisable, but some people do that because of emergency. So they break it by using a loop condition borrowed so-called from the while loop structure. So this condition, if you remember this green circular arrow, what are the three words? You through what? You see the three words you forgot, you see? These three words, stop if true, continue if true, better memorize it. Okay, continue if true is the meaning of this. Continue if true. That means if this wire carry a true status, boolean, this fella will loop and loop and loop and loop forever. But if you carry a false, what happens? You get out of the for loop lah, opposite. Okay? So now the condition to find out this output, is it going to be true or false? It all depends on this comparator, right? Greater than I. What is I? You know what is I, right? I is an iteration count which automatically increment starting from 0 as the loop loops. So you will start analyzing it this way. The very first time it loops, I equals to how many? Hello? I is how many? When the first time it loops? 0, right? 0 index start from 0, right? Not start from 1, not start from 0. Now you ask the question because it comes to this comparator. 0, is it greater than 75? So the outcome is true or false? False. If it is false, will it continue? Huh? No. Straight away get out. How many times the loop iterates? How many? What is I value? When I come out here, numeric. This I goes out to numeric. Numeric sees what? I go what? What's the number? The loop get out already, right? Is false, right? I is not greater than 75 is false. So it loops gets out. So what is I equals to? 0, still 0, right? And 0 goes out to this numeric. Numeric sees a 0. Okay? The loop already iterate once. But the I is 0. Why I equals 0? Because I is always 1 less than the number of iteration. Remember that phrase. I is always 1 less than number of times the loop loops. Okay? So not 50, don't see this big 50 for this for loop. This for loop will loop 50 times. No. No chance to loop 50 times because the condition break it. Okay? Unless you change this comparison to something else and this become false, then things will continue to loop. Okay? You can analyze your code. Remember. Next comes to arrays, and this is how we learn how to build 2D arrays or 3D arrays. The best way, the most efficient way to build arrays is to use what we call nested for loops. What is nested for loops? A loop within a loop. This is an example of 2 nested loops. So it will give you 2D array. So 3D how? 3 nested loops. Put another one, big one outside. Okay? So you just keep on putting nested loops, you get bigger and bigger size arrays. Bear in mind the rows and columns. This inner for loop will loop 6 times. The outer for loop will loop 4 times. What is your array size? That means array size means how many times how many. You know, you learn arrays, right? 2 times 3 means what? Means 2 rows, 3 columns. 2 times 3 array. The first number is number of rows. 2 times 3. Huh? So this guy is how many? What is the array size? Is it 6 times 4 or 4 times 6? Different, no? 4 times 6 means 4 rows, 6 columns. 6 times 4 means 6 rows, 4 columns. Different. You know what I mean? So this guy is what?
4 and 6.
Is 4 times 6. 4 rows, 6 columns. Got it? So make sure the outside is the row, inside is the column. Okay? And take note of this. You cannot create array of arrays. This is not permissible. I put a stress, a big red. There's a question that tested in a quiz. And I told you before, this final quiz tests some of the repeated question of the previous 4 quizzes. And I pick up some of this. You guys get it wrong, so I just want to highlight again. Don't ever think that you can create arrays of arrays. That means you create one array inside another array. You cannot. Still on the arrays, and when arrays are fed into a for loop, the question to ask is how many times the for loop will loop. So interestingly, if you just look at the number of times the for loop will loop based on this terminal count called n, the number is 10. If you just look at that and you say the answer is this for loop will loop 10 times, wrong. Straight away wrong. Because you fail to see what else was connected to the for loop. And you can see from this diagram there are 3 more inputs, and these 3 inputs are all arrays connected to the for loop. And I tell you, when you have additional inputs to the array, you have to look at these additional inputs. So the way to conclude how many times this for loop will loop, it depends on all these 4 inputs and all the rest of these 3. Who is the smallest? That will determine the number of loops the for loop will loop. Got it? So now, who is the smallest? Don't be deceived by that blue arrow I put down there. 5. Yes, 5 elements compared with 15 elements. Obviously 5 is smallest. But don't forget there is also another array called empty array. Empty array means what? No elements. 0 elements. So who is smallest? Obviously 0, right? Correct? So how many times this for loop will loop? How many? Hello? No answer. How many times this for loop will loop? 10 times? 5 times? 15 times? Or 0 times? The red word say already, smallest of the choices. So it's 0 times. If it's 0 times, what is the I value that comes out after that? Still 0 lah. The I start from 0. No chance to increment. Because the for loop never loops. Okay? In fact, the for loop, to tell you, when he see this particular code, because empty array was given to him, he never even go inside the for loop to execute whatever code inside. He never do anything inside the for loop. He just like, kind of like imagine that just fly over it. He just fly over it. He never execute. He never got the chance to see what's inside there. He just fly over it, and then he just take the value of this whatever appears here. Because I was starting from 0, this value, this tunnel is 0. So this 0 just given to him. Just take the value down here. It's taken from I. I is still 0. Right? So you get a 0 from here. Number of iteration is still 0. Okay. Then we move on. After arrays, we talk about clusters. So clusters, one good thing about clusters is that it allows you to mix data types into one block. Not like arrays. Arrays, you have to have the same data type in each defined array. Either the array elements are all Boolean, in one array. Another array you're going to define separately, give a different name, or numerics, or string type. You cannot have an array all different types mixed into the same array. You can't. Alright? But if you need that kind of situation, which is very common, for example, a student particulars, easily you can see 3 different types down here: name, graduated or not, what is his age, all different types. And so a cluster becomes very handy. Of course, cluster handling is a bit different from arrays. You need to put them together. First, when you create a cluster, it's all in one block, everything is in one bundle. But then one bundle, you cannot individually access those items and make manipulations on it, make changes. So you need to use function like this called unbundle function. You unbundle that bundle into separate items in that cluster. So one to many is an unbundled function, very obvious. And this one is unbundled by name. You can see all the different names of the items are shown here. If you just use unbundled without by name, then you don't see these labels listed. Not so obvious. I prefer to use by name all the time. Okay? So clusters can reduce a lot of wiring clutter. Too many wires, we can bundle everything. It's reducing all those wires. It is quite obvious. You see how wires are being bundled together to reduce cluttering. Okay, arrays, we also learn array functions. Make sure you revise those array functions in the lab that we have done. So initialize array is one of them. So you can see that there is these 2 numbers, 3 and 8, assigned to this particular initialized array function. So you must understand this 3 means what, this 8 means what. Okay, this 3 means I want to initialize the array with this number 3. And how much of it? 8. That means the length is 8. So for 8 elements, 8 of them, they are all initialized with a number 3 in them. The last 2 you can see is 0, but they are actually not really 0. It is dim. Dim means not initialized. Okay, so this is how the initialize function works, and make sure you know it. Array size, I think this one is quite also obvious. 3, initialize array, row and column. This is the same initialized array. That means I want to create an array which have inside that initialized value 3, and then then the size of the array is a 2D array because I have 2 constant here. 2 is for the row, 3 is the column. So you can see 2 rows and 3 columns, all with elements of 3 initialized based on this code. And after initialize, I want to find out the size of it. Okay, and the size returned to me is 2 by 3. 2 rows, 3 columns. This 2 by 3 will be shown up in this particular result after executing this array size. Array size determines the size of that array. And size of array determines by how much, what's the dimension basically. It's a 2D array, so you must have 2 numbers. It's a 3D array, you have 3 numbers. Okay? Array subset, we also use that in the lab, is to take a certain part of the array out, the information, not everything. So in this particular original array, it has all this data, 2, 4, 6, 8, 10, 12, 14, 16. But I want to extract a part of it from here, 6, 8, 10, and 12, this particular 4. Not everything. How to do that? Use array subset function. But how to use it? Obviously, you must fit the array in, the original array, and then you must specify the index where to start taking from the array, and then how many elements to take from that array. 4 is the length. So starting from 2, bear in mind the array starting point, the index is 0. 0 is this position. Index 0, index 1, index 2. So index 2 points at here. So I start taking from here, and I'll take a length of 4 elements. So 1, 2, 3, 4. Therefore the result is 6, 8, 10, and 12. Array subset. Clear? We done that in our lab also. Make sure you remember this. And this is talking about also shift registers. That is also part of the state machine. This pair of registers, I hope you remember, they are basically feedback loops. These two rows of data contrast shift registers that are initialized with a 1, and shift registers in this second row is not initialized. So this has impact in its operation. So you can see very clearly, the first run means the first running of the code. Second run means the second time you run the same code. Okay? You notice that the one with the shift register initialized with 1, the result is consistently producing the same result, 5 and 5. You can imagine the third run it runs, it also produces the same result, 5 at the output. But whereas the shift register that is not initialized, you notice that the output as it runs the same code again, it produces different results. Because why? Whatever result that was stored in the first run, the 4, is still contained in this shift register when you run the second time. So this shift register will get a 4 after the first run and continue to increase by 2, and therefore you see the output continue to increase. Because why? There's no initial value that you put into it. So this initial value is called initializing the shift register. It is very good. By default, if you don't put anything, it will start with 0. But the second time it runs, it's no longer 0. It was the result of the last run, which is 4 in the first case, 4, and continue to increase to 8 in the second run. And then it continues to increase. You can see 4, 8, probably the next number is 12, and 16, and go forth. Okay? So bear in mind, this is the case when you don't initialize your shift registers. This one I don't have to mention. This one we see umpty times. Last week, those who have done the practical test, I told you, if you produce this skeleton of the state machine with all the enums created correctly based on the state diagram in the paper, you get how many marks? 50%. And I would say most of you pass except for 1 or 2 who cannot complete the enum properly. Okay? In fact, 99% pass, except for 1, I think, who never get this enum done properly. Okay? So this is a state machine, and you guys are using it for the team projects. So please remember all the various parts that make up this state machine, namely the while loop, the case structure, the enum, and the shift register. Alright? Okay, I just want to quickly review some of those are the lab view concepts that you better get ingrained. Those are the focus on the questions this week. So if you understood all those, your this week lab view questions should be alright. Okay? And now I'm moving on to a few questions, not many, a few questions only on the test engineering concept, and these are the few questions that you must understand. First, you must be able to list out all the building blocks of a typical architecture of an automatic test equipment. I will just quickly browse through that later on. And then you must understand the steps involved in following how to assemble up a test system. And then the last 2 questions which we asked is what is functional testing and what is parametric testing. So I just captured these last 2 questions first because the answer is so obvious down here. So functional testing is to test the spec of the entire function of that product. Let's say it's your handphone. That means if your handphone can message, can call, can take pictures, all these functions must be tested. That's called functional testing. Functional testing is always at the end, almost at the final part of the product testing. Whereas parametric testing is testing the individual components as you assemble your parts. Let's say you put an IC there, and the IC is pretty expensive. Better test it after putting it. Because before you put in, it was working. But after you put it in, soldering process, what else you need to put it in, it may not work after that. So you better test it first before you put further more components. So those parametric testings are all done intermittently along the production line. And then finally it comes to the final testing, which tests the entire product. So there's a difference between these 2 tests. So once you got that understanding, you are fine. Okay, so now I'm going to list the building blocks. These are the building blocks of the automatic test equipment. Obviously, you need the controller, the main brain, the CPU, the PC normally, and then you have the switching system that switches between the source and the measurement. Because the source equipment are all the function generators, the multimeters, and then the voltage, not multimeters, the voltage sources, the current sources that forces signal into your test fixture where your unit under test is mounted. Okay, so this switching system will switch all the signals to connect to the signal sources and pump into your so-called unit under test. Then the next moment it will switch over to the measurement instruments like the scopes, the multimeters, to measure the signal or the response from the unit under test, whether those signals are present or present but not ideal, to make sure the board is functioning. And this kind of test is normally the parametric format. They test the various components. And obviously the final test also uses some of this system. So you can see roughly the setup looks like this. This is where the test fixture is, your PCs at the bottom, and your switching unit all at the bottom, and your sources and measurement equipment all at the bottom, and the monitors on top. Okay, so this is the architecture, and the boxes are the various components. Got it? These are, just explain what I just said, you just can read that. The 5 things that you need to take note when you assemble the test system is all listed here. Assembling the components based on the schematic, including the mechanical structure, the building of and also routing of the cables, the cable length, all these cables, okay? How you bundle them, how you secure them, is all listed there. And finally, how you ground them properly to prevent electrical interference due to noise, grounding of this signal. So these are the 5 elements that you could watch out when you assemble a test system. That's it.